Video is going to talk through the elimination method for solving systems of linear equations. So I would like for you to listen to what I'm going to say and stop the video and then write down the 4 steps. The most important thing to do when you're analyzing a system of equations and you're going to use the elimination method, you have to line up the x and the y with the operation, addition or subtraction, the equal sign, and the constant. So that means both equations must be presented either in standard form or in slope-intercept form. And then the second thing you're going to do, you're going to analyze the coefficients. The coefficients are the numbers in front of the variables. You're going to analyze the coefficients looking for additive inverses, like +5 and -5, or +1 and -1. And then you're going to add the 2 equations together in the third step to temporarily eliminate either x or y, depending upon which variables had additive inverse coefficients. You'll temporarily eliminate either x or y, and then you can solve for the remaining variable. And then when you get a variable value from step 3, you'll take that value back to either original equation, you'll place that number in, and that will enable you to solve for the other variable. It sounds like a lot of steps, but once you understand it and internalize it, it's actually pretty easy. So let me ask you to pause the video now, copy down the 4 steps, then resume the video and work through the problems with me. So I'm first going to do the system in problem number 1. So here, let's see, elimination is the method that we're being given. And you can see that both equations are in the same format. They're both in slope-intercept form. So you can see that the y's are lined up, the equal signs are lined up, the x variables are lined up, the operations are lined up, and the constant, the number without the variable. Everything is lined up as it should be, so that's your very first step. So here I have y equaling, I'll copy this over, just simply copying it a little bit bigger, copying the second equation, and then I can see that everything is lined up, and I notice that on the y variable, they both would have a coefficient of +1. But what I need additive inverse coefficients so that I can temporarily eliminate one of the variables. So what I could do, I could take the second equation and I could multiply each term by -1. So that's going to give me -y, -x, and that's going to turn this into plus a -2, which is just, or minus a -2, which is going to make that a positive number. And then once I have additive inverses set up with one of the variables, then I'm simply going to add the 2 equations together, just vertical addition. So here I'm going to have +y and -y. So y is going to be the variable that's temporarily eliminated from the system. And that's why the method is called elimination. Then I move over, I copy the equal sign down. I now have 3x minus 1x, leaving me with 2x. And I now have 4 plus 2, which is 6. So I now have a simple system, or a simple equation to solve, 2x plus 6. 0 equals 2x plus 6. So I subtract 6 from both sides, then I divide both sides by 2, and I see that x is -3. So remember, the solution to a system is an ordered pair. So the x coordinate is -3, and now I need to find the y value. Since I eliminated y, and I now have a value for x, I need to find y. So you can go back to either original equation, and I'll just go back to the simplest equation. Y equals x minus 2. If x has a value of -3, then y itself is -5. So the ordered pair solution for this system is the point -5, -3, -5. If I were to graph the 2 equations, they would intersect at the point -3, -5. But now we're learning algebraic methods for solving so that we don't have to graph to solve all the time. Let's do another problem. And now let's move on. Let's look at problem number 3 on the video. So in problem number 3, everything is lined up. I'm going to recopy. And when I recopy this, I notice that I have 3x and 3x. It would be better if I had +3x and -3x, setting up those additive inverses. So in order to do that, when I copy the second equation, I'm going to think of it as multiplying all three terms by negative 1. So that gives me negative 3x, positive 9y, there's my equal sign, and negative 15. And now, when I add the two equations together, when I do my vertical addition together, I can see that positive 3x and negative 3x sum out to 0. Then I have negative 10y and positive 9y, leaving me with a negative y. And then positive 14 minus 15 is negative 1. So I have negative y equaling negative 1. Therefore, positive y equals positive 1. So the first member of my solution is positive 1. And I now have to find the x. So I'm going to solve for x now. So I go back to either original equation, and I'll just go into the first one. And I let y take on the value of positive 1. So x is 8. So the ordered pair solution to this system is the ordered pair x equals 8, 1. X is 8, y is 1. If I were to graph this system, they would intersect at that point. Let's move on to number 8. And in number 8, I've chosen this problem because in number 8, they're not lined up on the first step. Even though I have the additive inverses, I can see that the equal signs are not lined up. And I can't solve the system until everything is lined up. So what I'm going to do, I'm going to take the first equation, I'm going to subtract 3y, and then I'll take this is my first equation, and then I'll take the second equation, and let's see, I'm going to rearrange it so that x and y are lined up. So the method doesn't work unless I have the y's, the operation, the x's, the equal sign, and the constant, unless I have everything lined up. And this is just simply the way that I'm choosing to do this. So I've rearranged everything, but I see that I've got negative 3y and negative 3y. So I'm going to take the red equation, and I'm going to think of it as multiplying each term by negative 1. And it just means that each term will take the opposite sign. So this will become positive. This is now going to become negative 2x. This is going to become negative 16. And now when I do the vertical addition in the first column, negative 3y and positive 3y sum out to 0. Positive x combined with negative 2x leaves me with negative x. And then positive 11 minus 16 gives me negative 5. And I need the positive x value, so I divide both by negative 1. X is positive 5. So the first member of my solution is positive 5. And I now need to find y. So to find y, I go back to either original equation. And I'll just choose the first one. So I find that y is negative 2. So the ordered pair solution for the system in number 8 is positive 5, negative 2.